In this video we are going to talk about heat engine. A heat engine is a cyclic device which operates on a thermodynamic cycle where it produces mechanical work when heat is given to it as an input. One part of this heat input is being converted into mechanical work, and the other part of this heat input, which is not being converted into mechanical work, is rejected out of this heat engine. This heat input given to the heat engine comes from a high temperature body. Let's say its temperature is TH. This heat rejected from the heat engine goes to a low temperature body. Let's say its temperature is TL. Let's say this heat added to the heat engine is QH and the heat rejected from the heat engine is QL. From this I can write QH is the heat input given to the heat engine, which is equal to work output plus the QL heat rejected. So it is W plus QL. So what is the work output? It is equal to QH minus QL. That is the mechanical work output from the heat engine. So what will be the efficiency of this heat engine? I can write efficiency of this heat engine will be some output upon some input. What is the output which is coming from this heat engine? It is a mechanical work. What is the input which is given to the heat engine? That is QH amount of heat supplied to the heat engine. So I can write efficiency of heat engine is equal to output, which is mechanical work, divided by the input, which is a heat given to the heat engine, which is QH. We already know the mechanical work is QH minus QL. So I can write W is equal to QH minus QL divided by QH. I can rewrite this again. Dividing QH, it will become 1 minus QL divided by QH. So now we know that efficiency of heat engine is equal to 1 minus QL by QH, and the mechanical work is QH minus QL. These both equations are valid for reversible engine and irreversible engine as well. This efficiency of heat engine equation equal to 1 minus QL by QH is applicable for both reversible and irreversible engines. But for reversible engine, efficiency of a reversible heat engine is a function of QL by QH as well as TL by TH, the ratio of the absolute temperature of low temperature body and high temperature body. So for that, for reversible engine, I can write QL by QH is equal to TL by TH. This is only applicable for reversible engine. So efficiency of a reversible heat engine I can write as 1 minus TL by TH. here we have a numerical which is based on heat engine. A furnace can supply heat steadily at 1200 Kelvin at a rate of 24,000 kilojoule per minute. The maximum amount of power in kilowatt that can be produced by using the heat supplied by this furnace in an environment at 300 Kelvin is, so we have to find what is the maximum amount of power that can be produced by this heat input. So let's see what is happening here. So we have two temperatures here. One is a high temperature, one is a low temperature. So I have one high temperature, I have one low temperature. The high temperature body is furnace, which is at 1200 Kelvin, and the environment is at 300 Kelvin. So low temperature body is environment, which is at 300 Kelvin. Now if this furnace provides some heat input to the heat engine, how much maximum work can be produced or power can be produced from this heat input? And of course there will be some heat rejected to the low temperature body, which is environment. So what is a heat input given by the furnace? So QH is the heat input given by the furnace, which is given as 24,000 kilojoule per minute. As we have to calculate power in kilowatts, I will have to convert this QH into kilojoule per second. So I will write 24,000 divided by 60. 1 minute is 60 seconds. Kilojoule per second. So QH will be equal to 400 kilojoule per second is kilowatt. So for this numerical, we know that the furnace is supplying heat which is 400 kilowatt to the heat engine. So I can write for the reversible heat engine, efficiency of reversible heat engine equal to power output divided by the heat input, which is QH, which is also equal to 1 minus QL by QH. This 1 minus QL by QH can also be written as 1 minus TL by TH, because it is a reversible engine. Discuss the efficiency of reversible heat engine is power output divided by the heat input, which is also equal to 1 minus TL by TH. So power is the unknown. What is QH? QH is heat input, which is 400 kilowatt. That will be equal to 1 minus TL. TL is the low temperature of low temperature body, which is environment 300 Kelvin. This 300 divided by TH. TH is the furnace temperature, which is 1200 Kelvin. If you calculate power from this, it will be equal to 300 kilowatt. So when a furnace which is at 1200 Kelvin supplies 400 kilowatt heat input to a heat engine, that heat engine can produce maximum 300 kilowatt of power.